So, picture this. There's this object, a traveler from a whole other star system, just silently cruising through our cosmic backyard. For months, it was nothing more than a faint speck in our telescopes. But then just recently, this visitor, they're calling it 3I/Atlas. It broke its silence. It sent out a signal, the very first one we've ever picked up from it. And now you can bet scientists are scrambling to figure out what on earth it's trying to say. And that's the big question, isn't it? What is this interstellar message all about? Is it just, the natural hum of the cosmos? Or could it be something more? That's the mystery we're going to dive into today. Actually, hearing this thing wasn't easy. It took a whole lot of patience. Astronomers were pointing our absolute best radio telescopes at this object, just listening. On September 20th, nothing, just cosmic static. They tried again on the 28th, still total silence. But then, on October 24th, as the object got closer and closer to the sun, a tiny, faint whisper finally came through. The Meerkat radio telescope down in South Africa is the one that caught it. And get this, the signal came in at two super-specific frequencies, 1.665 and 1.667 gigahertz. Now, those numbers are not random. In the vast static of space, a signal that precise, that's like finding a fingerprint at a crime scene. And that fingerprint belongs to something called OH radicals. Okay, think of it this way. You have a water molecule, right? H2O. When intense sunlight blasts that molecule, it can literally shatter it into pieces. One of those pieces is an OH radical, and it just so happens to absorb radio waves at those exact frequencies. It's basically a unique molecular barcode that shouts, hey, water was here. So let's be super clear here. 3I/8LAS isn't transmitting a signal like some kind of alien radio station. Nope. It's more like these OH radicals are casting a cosmic shadow. They're literally blocking and absorbing radio waves that are coming from way, way behind the object. And our telescopes on Earth are sharp enough to detect that tiny dip in the background noise. Okay, so we've got the barcode. We've detected this fingerprint for water vapor floating around this interstellar visitor. So what's the simplest, most obvious explanation for that? Well, the easiest answer is that 3I/Atlas is just a comet. A visitor, sure, but a comet nonetheless. As it swings in close to our sun, the heat starts baking its icy surface. That ice doesn't melt. It sublimates, turning straight into gas. And then sunlight zaps that water vapor, breaks it apart, and voila, you get the OH radicals we detected. It's a really clean, logical process. This is textbook comet behavior. It's exactly what you'd expect to see from a big old ball of ice and rock. It's a pretty straightforward, natural phenomenon. Case closed, right? Well, not so fast. There's a huge glaring problem with this simple theory. And this is where the story gets really good. Because while the signal itself seems to point to a simple comet, the way the object is moving tells a totally different and frankly much, much stranger story. See, 3I/Atlas is speeding up, but in a way that gravity alone just can't explain. Now, for a comet, that extra kick comes from gas shooting off its surface, kind of like a tiny rocket engine. But to get the acceleration we're actually seeing, it would have to have blasted off an absolutely mind-boggling amount of gas, 5.5 times billion tons of it. And if it lost that much material, we're talking about a sixth of its entire mass. We should see a massive, glowing cloud of gas around it. We'd expect a brilliant, spectacular comet tail. But when we actually look at the pictures from our telescopes, we just see a solid, compact object. Maybe a little fuzzy around the edges, but definitely nothing close to the enormous display that much gas would create. So now we've got this huge contradiction. The radio signal says there's some water there, but the visuals tell us there's nowhere near enough gas to explain why it's moving so strangely. So if it's acting like a comet, where in the world is all the missing gas? And if that puzzle wasn't wild enough for you, hold on. Because the mystery gets even deeper when we connect this object to one of the most famous, most tantalizing signals in the entire history of astronomy. You might have heard of it. Back in 1977, astronomers caught this incredibly powerful and totally mysterious blast of radio waves. It was so shocking, the astronomer just wrote, "Wow," on the printout. Now that signal clocked in at 1.42 gigahertz. And as we just saw, this new signal from Free Eye/Atlas is at 1.66 gigahertz. They are remarkably close neighbors on the cosmic radio dial. But here is the part that gives you goosebumps. It's not just the similar frequency. When astronomers traced the path of 3I/Atlas backwards through space, they realized it came from the exact same patch of sky where the WOW signal was detected almost 50 years ago. The alignment is nearly perfect. So what are the odds of that? What are the chances of that just being a random fluke? Well, according to calculations by astronomer Avi Loeb, the probability of this directional alignment being a pure coincidence is just 0.6%, less than 1%. That is, that's an incredibly small number. So what happens now? What do we do with all this? We have a signal that says comet. We have movement that says not enough gas. And we have this completely bizarre connection to an infamous cosmic mystery. The investigation, as you can imagine, is far from over. And there's a very clear next step on the calendar. On March 16th, 3I/Atlas is going to have a close flyby of Jupiter, and NASA's Juno spacecraft, which is already there orbiting the giant planet, is going to point its special antenna right at the object and just listen really, really carefully. If this thing is putting out any other kind of signal, Juno is in the perfect spot to hear it. So this is the puzzle we're all left with. Are we looking at the single weirdest, most bizarrely behaved comet humanity has ever recorded? Or are all these coincidences, the missing gas, the strange acceleration, and that spooky echo of the WOW signal, all pointing towards something else entirely? For now, we wait, we watch, and the search for answers continues.